Okay. I will start with my presentation. I just tried to explain it before the presentation, what I'm going to talk about during the presentation. And so, yeah, let me share my screen presentation. This one.
Okay.
So, hello everybody. My name is Jelal Sultanov. Today I'm going to talk about the CICD, continuous integration and continuous development in machine learning. Also about the automation of machine learning pipelines with Google Cloud. Uh, I'm for the last 2 years I'm doing machine learning DevOps and machine learning engineering. I'm also undergraduate student. I'm doing my last year, so I'm graduating this semester, doing computer science bachelor's in China University of Petroleum. So I'm happy to present you my presentation, and I will be happy to introduce the ML DevOps, machine learning DevOps in industry to you, so that in the future when you will engage yourself, will start doing career in IT or maybe in machine learning or AI, you would also consider machine learning DevOps. Uh, yeah, let's start with what is machine learning DevOps engineering and how does it drive business success. Uh, when we think of machine learning, we usually think of data preparation and model building. But according to a recent study, up to 25% of time of data scientists and machine learning engineers goes to exactly for data preparation and model building. The model is, in simple terms, is the algorithm, machine learning algorithm that recognizes, classifies, or gives some predictions to users. So that is called model. Model is, in other words, is just some kind of math algorithm implemented by code. So also, according to exactly the same study, up to in order to put the machine learning project or machine learning model uh, in, from the research stage to production environment where it could potentially bring the value to the business, on average takes from 8 to 90 days of development. Also, what's worse is that up to 75% of machine learning projects never go beyond the experimental phase or experimental stage. That is, in other words, up to 75% machine learning projects always stays at the experimental stage and never gives or brings the value to the business in terms of some kind of revenue or some kind of attracted clients or customers into
I think some problem,
Yeah, I would
but I have no idea what happened.
Uh, Извиняюсь, I'm sorry for disrupting the video. I mean, suddenly my internet connection broke up. Hello, do you hear me?
Yes.
Okay, okay. Let me continue the presentation. I'm sorry for interrupting. So, what's worse is that up to 75% of machine learning projects never go beyond the experimental stage. That is, in other words, up to 75% of machine learning projects never give some or bring some value to business in terms of revenue or attracted customers to any project or any problem that is business is going to solve. So what it gives, what benefits it give to business is that there are four benefits. All they are mutually dependent on each other. So let's start for the first one. Is that more time for development of new models? Let me start with another story. I mean, ML DevOps, machine learning DevOps, is has one main goal: is that as a fusion of machine learning and DevOps engineering, it represents the combination of methods that is going to solve or automate the whole life cycle of machine learning project, starting from model training, starting from data preparation up to model training and deployment. So when you when you're trying to solve any problem with machine learning, you need to, first of all, you need to get some data. I mean, all AI projects work on data. So you need the data in order to train a model and deploy it somewhere online. So so that your customers could get some online results or online predictions from the cloud. Imagine the Netflix. So the Netflix website has customers and it has some website. When you enter the website, the Netflix website tries to give you some recommendations based on your age, race, the place where you live, also and other factors of the person. So all that predictions, all those predictions are made somewhere in their databases, their uh, data clusters, and all those predictions are made automatically. So that is what machine learning DevOps means. So yeah, there's a classical machine learning, scientific machine learning industry, and imagine like there's also another industry like machine learning DevOps. Machine learning DevOps concentrates on applications, real applications of machine learning in the real world. So people, businesses are trying to uh, uh, solve the problems with machine learning. So some some group of people work on like on implementing a new algorithm, machine learning algorithm. Other group of people try to use all those implemented algorithms just in production, just to solve some kind of problem. So that is what machine learning DevOps means. So uh, it, because machine learning DevOps has one main goal to automate all steps, like starting from data preparation to model training, with the emergence also with emergence of machine learning DevOps industry. Now, data scientists and machine learning engineers have more time for development of new models. So, since the emergence of machine learning DevOps, now data scientists can only concentrate their attention, their time, efforts on implementing new algorithms, new methods of solving problem, but deploying all or testing the model. It can be done by DevOps engineers. Like if you have trained model, the next stage is to deploy. I mean, deploy somewhere online. The deployment is done by DevOps engineers, IT engineers. So because of that, now, as I said earlier, the data scientists and machine learning engineers have more time for and more effort. They now can concentrate their attention on building and developing new models. I mean, models equals to math algorithms, but just in Python or any code implementation form. The second one, as I earlier said, once machine learning project is automated by the software, starting from getting the data. I mean, you need to get some data. You need to prepare the data by different methods. Also, you need to clean and feed it to the model, feed it to the machine learning algorithm, and train it and have a already trained model at the end of pipeline. So all that is called machine learning pipeline. Like it starts from the data ingestion. In other words, just getting some data from any source, any source. So once all that pipeline is automated, uh, the time that is needed to go to market for machine learning models becomes shorter, and that in turn gives the better user experience. So now machine learning models can be updated more regularly, more frequently, so that users or the users or business leaders could get results faster, more frequently, and of course, the development of machine learning models always gives some better results than it was previously done. So that is in turn gives the better user experience. Uh, the last one is higher quality of predictions. As we know, there's a tendency for the data to be changed from time to time. For example, when we today train a model, machine learning model, the data after the week or after 1 month can change. And for that reason, we need to update regularly, more frequently, our machine learning models just by new data. So when you launch the machine learning models into production, you need to always regularly update your models with new data, because data can change. Customers can come and quit from your websites, from your project. All your models should be reflecting those changes uh, at your servers, so that it can be always obtained, so that business leaders, users can get higher quality predictions. Okay, uh, let's go into other slides. Machine learning DevOps concepts and workflow, repeatable MLOps workflow. So as I said earlier, the whole pipeline, the whole logic of the machine learning DevOps is called training pipeline. So the pipeline starts with the data ingestion. As you already may know, as I earlier said, all machine learning projects, all AI projects, they all need some kind of data in order to be trained, in order to be able to give some recommendations or predictions. So you need the data ingestion step, then you need to set up data validation. It's also important to remember that not all of the data is needed for training, or not suitable, or not all the data meets our data expectation or the requirements that we have uh, for the data. Then, after we are sure that data is correct, after we are sure that we have some data, we need to prepare it. We need to clean for the model, for the machine learning algorithm. Uh, so because machine learning model in its turn also expects the data in some kind of limitations. For example, uh, when you feed the model with the images, when you're trying to make a computer vision model, you need to prepare the images and make it all images in one dimension. In one size, so that all your images of your data set in your data set have the same exact dimension. Let's say 20, 250 pixels height and 250 pixels to the width. So it's all standardized in data preparation step. Then model training, finally, model trains, learns based on the data, based on the problem you're trying to solve. Then the developer machine learning engineer evaluates, gives or sees the model performance and validates its performance. So if the model meets our expectations, requirements, then we register the model into our registry. So in machine learning DevOps engineering industry, every your step should be recorded as much as possible, starting from data ingestion. You need to record from where did you get the data, how did you get the data, who was the source, who was the source of the data. Then you need to also store the validation methods, data preparation methods, and what's most important, you need to secure your model into some kind of model registry, because when you will deploy your model, you need to choose one model from model registry, the model that whose performance was the best among others. Performance, by performance, I mean the best predictions, the best performance among the other models. So also, when you have model registry, when you have the best model to deploy, you need to just deploy it. In other terms, serve it. You deploy it somewhere online, and you periodically need to monitor the performance, because as the data can change over time, the model performance can also drop in its performance. In its prediction values, because just uh, for example, you train the model today, and after the month, data can change, and accordingly, models performance also change. So that also need to be automated in machine learning pipeline. Imagine you have some kind of drop in model performance, and if you want to automate this model training, I mean, you need to set up some trigger in your pipeline, so that all this process starts from the beginning just by automation. You don't need to touch it with your hands. You don't need to serve it manually or something like that. All these steps should be done by automated scripts and codes. So when you will the when you will set up machine learning DevOps projects, you need to set up some kind of trigger or some kind of code that will monitor your performance all the time. When they will start performing Hello, do you hear me?
Yes, we can hear you. Uh,
I'm sorry for it's on my side. I mean, the network issues. Apart from then, from that, all do you hear me? I mean, can you hear me
yes, we can
clearly?
hear
Do you
you.
hear?
Yes, 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 yes.
Okay, okay, okay. So let me continue from where I stopped. So all this pipeline can be started according to the requirements of the business. It can be started even once a week, once a month, or it can be started just manually. The business don't need to start the pipeline too frequently, and maybe business wants to start it once a year or twice a year. So that in that case, it can be done just manually, just by developer. Okay, let's continue with the other slide. Key components of machine learning DevOps. There are five key components of machine learning DevOps. The first one is model training pipeline. In this stage, the machine learning engineer sets up the machine learning pipeline, starting from data preparation up to model deployment part. So the pipeline is some kind of the code or software that combines all these steps into one. And when you launch the first step, other steps are launched automatically, step by step. So when you have a data, when you will give some data into a pipeline, when you will enter some kind of data into pipeline, data preparation, data cleaning step will start, and after you get clean data, prepare data, your machine learning training, model training step will start automatically. And once you have trained model, your model machine learning model will be deployed into the place where you will direct the model. I mean, where you will explicitly write in your code where to deploy. The the second step is that model registry. Once you have trained model, trained algorithm, machine learning algorithm, you need to store it somewhere. And also the developer needs to set up some kind of registry so that this registry can save uh, save the model and compare models with each other automatically and just output your model uh, that gives your best results or predictions. The third one is model serving, or just in other terms, just deployment. As I said, once you have the best model, train it model, you need to just deploy it. All these steps are done by automation scripts, codes that is written by a developer. And also the fourth one is model monitoring. You need to also set up some kind of code that will monitor your model, because as I said earlier, uh, the model performance can drop in its performance predictions or in other values, and all this should be monitored automatically. And all these steps are called and done by CICD orchestration. So what is CICD orchestration? In classical development of software, there is a term of continuous integration and continuous development. When you develop some kind of website or application, you need to frequently deploy your application to the public, I mean, to the, let's say, App Store or Google Play Market. So in order to be able to quickly iterate or quickly deliver your ready to use application to customers, to your users, there is a term that is used in IT industry that is continuous integration and continuous development. So when you write the code, imagine this life cycle of development of any software. First one, in the first place, you plan some kind of project. What's your plans? What is your goals in terms of values? What are you going to achieve by this project? Once you have a ready plan, you need to write some code that will solve that problem. And all your code should be built together. I mean, your code is kind of, is like, usually is like set of parts of whole code parts that in the end can be built together, and that can be turned into some kind of application. So you have lots of code files. So once you finish writing those code files, you need to build it. And build, after you build, you have some kind of application, a ready to use application. And once you have an application, you need to test it. To test it, I mean, uh, does it does it meet your requirements, or does it have some bugs in the files, and so on. When you have tested and have a ready-to-use application, you release it into public, into online, and deploy with the following operation step. And of course, you need to monitor it periodically. So all this life cycle is called continuous integration and deployment or development. So when you write an application today, let's say we start writing application today, and we deploy it at the end of the day deploy it into the Apple Store. And tomorrow, when we continue working on another feature, on another functionality of the application, we need to just update the code, update the dependencies, update the logic of the code, so that your new code doesn't disturb the old written code. So all those codes are working with each other, so that no part of code disrupts each other. So that is called continuous integration and continuous delivery deployment. Yes. So there is also another term, continuous training, in machine learning DevOps industry. This is uniquely belongs to machine learning DevOps engineering, because, as I said, model can degrade over the time, and you need to frequently train the model with the new data, and that is called continuous training. Every time, always, you need to monitor, measure the performance, and in the case if your measure drop, you need to retrain it automatically and serve it or deploy it again into the online. So that is what continuous integration, delivery, and training means. Okay. Some use cases of machine learning DevOps in industry. So there is a company, Datatonic company, that develops some application for users, so that when user comes to market, the physical market, he or she can just use the mobile phone's camera and take a picture of the product that he wants to take or buy. And the model or the machine learning algorithm on the phone will detect what kind of product he is going to buy, or what's the amount of the product, and all those tasks are done by machine learning. And online, I mean, when the user points his camera into the product on the shelves, I mean, market shelves, the model detects it and uploads it into Datatonic servers, exactly the Google Cloud service. So this is how is their logic looks like. And the first one is just image upload. When they have image uploaded, they convert images to TF records. TF records means some the data format for in order to train the model, machine learning model using the TensorFlow. That is some specifics of using TensorFlow. TensorFlow is machine learning framework, the framework from the Google. So in order to train a model, when you have a data, you need to convert that data into TF records format, data format. So then you split the data into train, evaluation sets, and the next step is data augmentation. There is also a new, or not new, there is also step data called data augmentation. When you have some kind of lack of data set, lack of data that is needed for machine learning projects, you need to augment the data. For example, from one image you can make multiple images, but with some modifications. Maybe you need to, maybe you will need to update the color. Maybe you will apply the color adjustment or size adjustments. All those methods are called data augmentation. All that needed to augment the data you already have. And then once you have data augmented, the ready to use data, you need to train the model. I mean, this is how the logic looks like. After they have data augmented, they train a model and evaluate their performance, and of course store the evaluation metrics. This is their model registry. They just store the evaluation metrics in BigQuery, and once they have needed model, the best performance, they convert model to TF Lite. TF Lite is uh, the file, the model file that is used in iOS or Android development. TF Lite means like you have trained model, some model, and you can use that model in your applications, and that file is called TF Lite. Lite here means like light version of the model, TensorFlow model. And then you just deploy it on the users' phones and regularly check the performance. And here, have a look here. This is called a data preparation step. And then this is machine learning step. You first get your data, augment it, prepare the data, clean the data, and next step is training the model. And of course, as I said earlier, all these steps are done by automation code or machine learning pipeline, machine learning DevOps pipeline. Yes, this is the use case of the machine learning DevOps project in the industry. The next slide is MLOps practices. The practices were maybe once you will decide to build a career on machine learning DevOps, I recommend you to follow these best practices in machine learning DevOps. So the first one is naming conventions. Of course, doesn't matter where do you write the code. Is it a machine learning project or just classical programming like application programming or website? You always need to uh, have naming conventions. I mean, your variables, your functions need to have some clear names so that uh, after the development, when you will come back to your code and will have will look have to the your code, you will not disturbed by the naming you already wrote. So your naming conventions should be clear. So the second one is the code quality checks. Your code should always be clear and concise as much as possible. The third one is experiment. The experiment means before the deployment of the model or before the data ingestion or preparation, you always need to have some model that you think that this model is going to be the best in the application. So usually the machine learning developers, machine learning engineers sit and develop some kind of and experiment with their models and see or try to come up with the best model or best algorithm. And all that step is called experimenting. You need to experiment, have to find the best model or see or do some research online and try to find the best model that will suit your project. What I mean by track your experiments, your experiments when you will be experimenting in your projects, you will always have some results. Doesn't matter the best results or the worst results. You always need to track it and store it somewhere online. For example, when I do the projects, I always track my experiments using ML Flow. So whenever I train a model in my experiments, I store the metrics, how much data I use, where did I get those data. All those information I store in my project in ML Flow. ML Flow is just kind of some tool for experimenting and tracking experiments. The fourth one is data validation. As I earlier said, not all of the data you can get fits the requirement or meets the requirements you have towards the machine learning model or data set. So you always need to validate your data. The fifth one is model validation across all data segments. For example, there is also some specifics of machine learning projects in industry. When imagine we want to set up some kind of classifier of dogs breeds. Imagine we have to classify 10 breeds of dogs. And when we have a trained model, the best model, the model shows us like 93% of accuracy on all across all dog breeds. But that metric can be falsely accepted. For example, that can be should be of course validated across all data segments. I mean, when your model outputs the overall results of 93% or 95%, you always need to go across all data segments. Like data segments means in our case dog breeds. Check the model if model performs good on the first dog breed, then check the model if whether the model behaves good on the second breed or and so on. So the overall performance of model across all data can be good, but when we will be checking the model performance on specific given data segment, we can have some performance drop of the model. So that is some kind of specifics of machine learning projects. So the next one is resource utilization. Remember that your experiments cost money. So whenever you utilize or use the resources, I mean, resources here means the computational resources like GPU or CPU all machine learning models requires us to have some kind of good resources, good GPU power. And when we go to the market and try to seek some kind of solution to our resources, we we can see that all those resources cost money. For example, AWS offer their computer power to us just for for money. You pay for them, and they offer you some given amount of GPU power, computer power. So you need to always remember that your experiments cost money, because you can forget about it, and at the end of experiment you can find out that all those experiments were expensive to you or to business, so that can be problematic at the end. The seventh one is model predictive service performance. uh, Monitor the predictive service performance. Yeah, model can degrade, can change its performance. You need to always monitor it. The eighth one is think careful about your choice of ML platforms. So in the market, for training machine learning models and setting up the machine learning pipelines, there are plenty of solutions from Google, um, AWS, Amazon, and also from Microsoft Azure. So when you will be setting up your platform, machine learning model and pipeline, you need to think carefully, because uh, some businesses train their model in one platform, let's say Google Cloud, and deploy it in another platform like AWS. That can be problematic, because when you try to integrate those parts with each other, they usually cost money, or that those integrations can be very problematic in terms of technical implementation, and finance in also in financial terms, because always you need to always transfer from one platform to another, and all those transactions of the data cost money. So it's always, in my opinion, it's always good to choose one platform, and in one platform have a trained model and deploy the model itself. So the next one is open communication lines are important. Okay, when developers, machine learning developers, develop some machine learning applications, they always need to be in touch with business leaders, business owners, so that they are on the same page. They are trying to solve the same problem, or trying to achieve the same problem, the same goal. So for business leaders, owners, it's also important to know what is possible to do and what's not possible to do by in terms of technical implementation. Uh, for example, uh, business leaders would like to see the model performance of 95 or maybe 100% of performance, but when we start developing the model, we can find out that this is not possible, because the current research state in our world didn't achieve that level of performance. So it's also important to know for business leaders what is possible and what's not possible. So that is called open communication lines I pointed. Score your ML system periodically. For example, when you score your ML systems, over the time, new solutions, new algorithms can arise, can emerge in the market. So that it's important to also monitor or do some periodically researches on your own. So for example, maybe your model is outdated, and maybe there's a new model that solves the same problem, but with better performance, but less data, and so on. So that's why you need to score your ML system and do some researches periodically. That is all for the 10 best MLOps practices. The next slide is ML experiments with Google Collaboratory. So this is the service from Google where just from your browser can experiment or write Python code and share it with your friends or colleagues in your work. So what is Google Collaboratory? Google Collaboratory is a service that gives you computational power in terms of GPU, CPU. So that is needed for developing or training the machine learning models. So all your experiments development can be done in just one Google Collaboratory because I use it frequently in my development stage and in my experiments also. The benefits it gives to users is the first one is sharing. You, I think you all use the Google Documents. It's the same as Google Documents. You just have some button, and when you click to that button, you can share your file, your code file, with other work colleagues and send them this file. And in one file, you can edit, develop up to several developers. So all developers can be on the same page of the current development stage. So the second one is versioning. You can save your notebook to GitHub. Notebook here means the Python file that is used to develop it, that you use for development. You just need to write some code in your notebook. And in case you need to version it or store your changes somewhere, the Google Collaborator supports the Google GitHub, and in just one simple click of button, you can save your code into your repository and on your GitHub, and stored uh, uh, have stored your changes very quickly. Okay, the next one is code snippets. I think you know what does mean Python notebook. So uh, it's different from the classical .py Python file. So in notebook, you have code snippets, blocks of the code that is um, that is good when you start experimenting because you can run different blocks independently from each other. So so that it's very important or comfortable for your experiments. So yeah, that is the third benefit. The fourth one is performance. The performance is how much GPU power does Google Colab gives to users. It is around 11 and 12 gigabytes of GPU of free power. The price is free for everyone. That this power is enough for university projects or some kind of user-friendly projects of machine learning. And the fifth one is, of course, this is all free. You don't need to pay anything exactly for this power. But in case you don't have or you run out of the power, you can just pay pay money to the Google, and the Google will provide you with more power up to 20 gigabytes of GPU. So that's what Google offers us. I mean, us to machine learning researchers, engineers. The next one, the next slide is machine learning DevOps with Google Cloud. Okay, I tried to make the presentation more related to Google Cloud technologies. So this example will be related to the Google Cloud technology. Okay. Uh, what is Google Cloud and what is Google Build platform? This is the fully managed CICD platform. When you are done with the writing your code, your pipeline, your machine learning pipeline, you can just upload it to the cloud build, and the cloud build will start the machine learning pipeline automatically and build your code, assemble your code parts into one part, and the next stage is it will start the testing. I mean, in classical development or software development, you have some kind of testing stage. You need to have set up. You need to set up some unit tests. You need to set up some unit tests for models, for data. You have all those tests are, once all those tests are passed successfully, then that application or your code uh, is deployed to virtual machines or into the cloud that you will mention in your code or will explicitly uh, say Google Cloud builds where to build, I mean, where to deploy your model. The next is how does cloud build work. Once you have source code, your ready to use code, you upload it to cloud build, and cloud build will start uh, building steps, and at the end we'll deploy it into uh, Firebase or Kubernetes engine and so on. So that is how cloud build works. So whenever you will need to set up some kind of machine learning pipelines, you can use cloud build in your applications, in your projects, because it has so many benefits in terms of uh, fees that you need to pay, because all Google Cloud technologies, Google Cloud Build, have some benefits from other, I mean, benefits uh, in terms of financial fees that you need to pay. Because the uh, first hours of using of every day, they are free for developers. This is uh, this differs from other solutions or other providers like Amazon AWS or Microsoft Azure. So that is the uh, main benefits. Also, it corresponds, it meets the basic security requirements, the corporative security requirements, and this can be securely used in your business applications or in your company. So all those are ensured that, I mean, there is no uh, security issues with the cloud build. So the next slide is the end of the presentation. Thank you for your attention. If you have any questions, or maybe you didn't understand some parts of presentations, or something else, I will explain it now. Please feel free to ask.
Yes, so far people have not dropped questions in the chat, but I've been dropping some definitions of some terms. But I've got some questions that are topic related and some which are not really topic related. So what is the difference
Okay.
between general DevOps philosophy and machine learning DevOps? I'm sure you probably said it, but as I understand, in machine learning DevOps, there is this uh, data engineers that come into it, right? And that's what makes it different from the general DevOps, right?
Mm, yeah, yeah. Yeah. What's the difference between machine learning DevOps and classical DevOps is that in machine learning DevOps industry, there is also continuous training step. That is, when you have a model, the the model, as I said, can degrade over the time, and you have to update your model with continuous training, with continuous updating your model, with continuous getting your data into your databases. And that's the main difference between DevOps and machine learning DevOps. Yeah.
Okay. And there's one question in the chat.
So,
Can you take a look?
yeah, let me see the question. Just a second. How long does it take to create a model? It depends on the problem you're trying to solve. For example, there are some complex, very complex computer vision models that, for example, classifies or segments the images, or imagine, for example, machine learning model or computer vision model of the Tesla. You all know what Tesla is, how Tesla works, the autopilot of the Tesla. And inside of the Tesla car, there is a computationally powerful computer that is trained to detect the pedestrians, cars, trees, and so on. That model is very heavy compared to the recommendation model that, for example, uses the Netflix. For example, the model you need to train for the Netflix uh, is less powerful or less complicated than the model of the computer vision. So it depends on your task, problem you're trying to solve. But if being concise and short, I would say that in 1 hour, you can create your one basic model to classify some cats and dogs in computer vision, or work with tabular data. I mean, when you will want to, uh, when you want to give some recommendations, for example, if you have some website, you can set up that model in just 1 hour or 2 hours. Just some basic model.
Thank you. The next question is, are data scientists and machine learning engineers the same? Or can these terms be used interchangeably?
Sometimes they are used interchangeably. Sometimes they are used independently. I mean, data scientists, in my opinion, are more concentrated on the data preparation, data uh, aggregation step, and also the model building step. So when there's on the machine learning project, there's a lot of steps, and the beginning of the machine learning project starts with the model building. For example, when you start a project, you need to set up or develop some model, or in other terms, some to come up with a uh, math algorithm that will solve your problem. So that development of the math algorithm is done by mostly by data scientists. And what machine learning engineers do mostly is setting up all those pipelines, setting up all those steps together, combining those steps into one pipeline, and having it deployed. Usually, those that work is done by machine learning engineers. But sometimes, as I said, it can be changed interchangeably.
Okay, great. Thank you for the clarification. And so Behruz is
Thank you.
asking, how is machine learning different from building neural networks? The question is in the chat.
Yeah, the, the building of neural networks is directly related to machine learning, because neural networks is some kind of subgroup of the machine learning. Because what machine learning means is that people trying to train some kind of machine or algorithm to train on the data in order to solve some problem. And all that is done by neural networks. Neural network is some is a method or idea of building machine learning. Neural network is neural network is uh, duplication of human brain cells, and all that combination or all that logic is done by machines or written in the code and trained by machines. Yeah, there is no at all. There is no difference between machine learning and neural network. It's just subgroup of the machine learning. But neural networks is some kind of uh, duplicate, or it repeats how uh, human brain cells works.
Okay.
Okay, that's another question. Is there any difference between the machine learning and artificial intelligence?
Yes, machine learning is also subgroup of artificial intelligence, and in artificial intelligence there are a lot of subgroups such as deep learning, machine learning, and machine learning means like usually it means some simple models like recommendation models that are light, that are that don't require a lot of data in order to be trained. But deep learning models, for example, require a lot of data or more complicated than the machine learning models. So machine learning is just subgroup of artificial intelligence.
Yes, I've read somewhere that AI systems are concerned about maximizing the chances of success, while machine learning is mainly concerned about accuracy and patterns, right?
Yeah.
Hmm.
Exactly. Exactly.
And my next question might sound very basic, very primitive, but that's something sort of logical for me to ask. So where does an indie developer, for example, can get a large amount of data in order to, uh, as you said, to train the model? Because it's a very logical question. How can I get that amount of data? For example, on
Mhm.
Instagram, we might help the application, the users themselves, they help the application by tagging people, right? By uploading
Mhm.
pictures.
Yeah.
But where
Mhm.
does, how can one
Mhm.
get a large amount of data, where it's not a company?
Mm. It's very good question because this question is also always is asked by machine learning engineers when they start the machine learning project. For example, okay, the plan is defined, the goals are defined, what we are going to solve, and the next question arises from the developers and also from the business leaders is where do we get the data? So depending on the project, of course, uh, there are a lot of sources of data. For example, imagine we trying to develop some simple classification model of dogs and cats, and in that case, we need to just go to the Google and just Google dogs and cats. For example, start with the dogs and go to the image part of the Google and get or download all the data from the query result and store it on your computer and prepare it for further training, model training. And the same process can be applied to the cats. So for the classification task, you need to just you can collect the images by your phone. For example, you can go out to the park and take your phone with yourself and take pictures of the cats and dogs from the different angles, from different perspective, with different lighting conditions. So it can be also done manually, or you can just download it from the internet. Or, for example, imagine like Google Translate. All we use Google Translate in our studies, work. So if you notice that there is a button of offer the translation or something like that, so users can themselves offer the correct translation of the foreign word or sentence. So that is also a kind of method of getting the data, the correct data. That is good for machine learning project if there's a way for users to help with your data ingestion step, so that users can also participate in data collection part. So overall, it depends on the project, but in my opinion, it's always good practice to have some functionality for users to to offer you some kind of new information or new data or something like that, that in result can can help with your model performance. Yeah.
Okay. But has there ever like, do you think that there is some sort of machine learning project or some sort of machine learning powered application where it's super, super hard to collect data?
Ah, machine learning. Okay, I got you. Uh, yes, there are some projects that uh, the projects where it's hard to get the data, and in that case, maybe you need to stop or try to change the business goal or the business objectives that business or company trying to solve or achieve. In that case, uh, it is recommended when there is no data. Of course, everything can happen, and that is applied to the machine learning projects. When you're trying to find the data, it's not guaranteed that you're always going to find the data. And in case you don't find the data, maybe you need to change the business goal or business problem you're trying to solve. That is what I can say. But for now, I don't remember such project where it's hard to get the data. I'm sure that there is there are some projects that is uh, have some problems with data aggregation or data ingestion, but for now, I don't have any such projects.
Okay, I think I also understand you, but in the very last question, a very follow-up last question to this question is that are there any, could there be, and can there be any sort of legal issues, copyright issues when a developer tries to use some other people's data? So for example, you suggested,
Mm.
just Googling things and downloading all the images that popped up, but those images are not yours.
No.
They are owned by other
Mm.
people and internet users. So does this thing concern
Mm.
developers in machine learning environment?
Yes, this is very concerning problem, concerning issue in machine learning industry, because imagine there are also some projects like that tries to scan the X-ray images of the patients and try to find some abnormalities or some kind of diseases on the X-ray image. In that case, you can ask how that data transfer or data utilization is performed, because X-ray images are some kind of personal information or the information that only belongs to patient and his doctor, and how it can be performed or built or developed in machine learning. I can, I'm sure that there is in those cases also, there are solutions. For example, in order to train a model that scans the model and scans the image and tries to find the abnormalities in the images, the model does not need any personal information like age of the patient, gender, or the race of the patient, because in in the hospitals, along with the X-ray image, with the X-ray image in that file, in the X-ray image file, you also have the information, the private information of the patient. So let's say the name and the surname, the age, gender, his nationality. All those information are not needed for the model training, and thus it can be said that we don't use any personal information. We just need to have just need to have uh, X-ray image, and that's all. I mean, yeah. So it's very concerning problem in the machine learning. There are a lot of solutions to solve the security problems and data privacy issues. But in that example, I try to show you how it works, and not all the machine learning models need to have like private information or something else. It just needs some some representation of the patient or person.
Thank you for the answer. And if you've got a few minutes, I would like to ask a couple of questions related to your early career and not like topic related. So if you can share how, when, and why did you become interested in machine learning?
Mhm. Uh, when I was starting my bachelor's, when I was in my first year of bachelor's, I was very fascinated by how computers can quickly give some predictions in in such little amount of time with such high accuracy rate. And when I started to do the research on this topic, I found out that the AI itself or machine learning is just some kind of repetition of the human brain cells. And I was fascinated by how this system works. And frequently, day by day, I started interested in computer vision, doing computer vision projects, and that is how I started, and how I was interested in AI. Yeah.
So that was like in the very first freshman year of your bachelor's degree, or like what?
Yes. Yes.
Uh,
It was in my freshman year on my bachelor's degree. So I was fascinated by how other developers develop very cool machine learning models that can detect, classify, or recommend you new things, uh, new things. Yeah. For example, there are models that generates the images of people that you can't differ from the real people. So they are called GANs. So I was also fascinated by that technology. Yeah.
mhm, mhm. Okay, and since we are also developer students, I would like to ask you
Mhm.
what kind of courses or subjects or elective courses should one take and learn in order to get on the path of becoming a machine learning engineer or data scientist in that area?
Mm. Uh, there are plenty of online courses that are recommended for AI developers or for the students themselves. I mean, you all know about the Coursera or Udemy platforms, e-learning platforms where you can attend the courses and learn some new things in AI. And my recommendation is, first of all, go to the Coursera and try to find some courses, some practical courses in AI, artificial intelligence, and try to do some machine learning projects after you end that courses, because in the courses you learn something, but that is not enough for the AI or for the AI applications. But after you learn or attend online courses, you need to start to do your own projects, or you need to just start using the GitHub or browse it on the internet, try to find similar projects that you want to do and repeat those projects. Because by doing applications, by doing real projects, you learn a lot of things, much more things than you learned during the course. The course, of course, it's recommended start with the course, let's say from the Coursera. There are plenty of courses. I can drop you the list of needed courses for the students in order to become AI engineer or an AI scientist. But the overall recommendation is start from the online platforms like Coursera, and then start doing own applications, own projects, and publish it on the GitHub.
Okay, thank you. When I was asking the question, of course, going to such educational websites such as Coursera or edX are one of the best solutions to start learning, right? Machine learning or AI. But in my case, I meant some must take courses from that university might offer. So, for example, from the math department, should we take, for example, theory of probabilities and math statistics? Some must-take courses that might be offered from
the probability, the probability is must-have course that every AI engineer or machine learning data scientist engineers should have passed it already. Of course, the first one is linear algebra. It should be started with linear algebra because in AI, most of the operations are done by matrices. And that is what linear algebra gives to you. So in a linear algebra, you study how matrices works, how they interact with each other, how to manipulate with matrices, and so on. That is the first one. The second was statistics, and the most important is probability course. The probability course. Then goes with programming courses like Python. I recommend start with Python because it's easier in implementation and also in the learning, in grasping the Python language itself. Then so those courses are the best recommendation: linear algebra, statistics, and theory of probability.
Yes, and I'm very glad that it turns out that hopefully we have all of them. And students right now, we've covered linear algebra already in our freshman year. And and we've got some elective courses in machine learning, introduction to AI. So I think we're good if someone decides to become a machine learning engineer. So that was it from my questions. And I wanted to say, and thank you for your time, Jelal. We appreciate sharing your input of knowledge and experience with students of our university. You're located in Bishkek, Kyrgyzstan, as you know. By the way, have you ever been into our country?
No, but I'm dreaming of being there because I was in Kazakhstan, but in Central Asia, I was already been in Kazakhstan, but never been in other countries of Central Asia. So I'm thinking of visiting Kyrgyzstan and Bishkek also. So yeah.
Okay, then I hope that you arrive and I hope that you like our country and have a pleasant experience. Yeah, and so to me,
Thank you.
yes. So to me, it's actually the first time where I dedicated my time to learn more about machine learning related topics. Because of course, as a developer student, one might have heard of machine learning and AI in general, but this is, in my case, the first time where I sit down and listen to something related to machine learning topics. So I hope it was helpful and informative for our students. And Jelal, if you have some questions, you
Yeah.
can ask, and then we can wrap it up.
Yeah. Okay. I hope you all understood the presentation. I tried to make it as much as user friendly. I mean, as much as possible. If you have any questions, please have it here. Write it in the chat, or maybe you can ask. Maybe after this presentation, you can ask me on the Telegram. You can add me here. Let me share my user ID in Telegram. So in case if you have any questions, you can always write me in Telegram. I will always answer you. So I tried to make it as simple as possible. I understand that this term machine learning DevOps is maybe new to you, or some parts were unclear. Yeah, but please ask it. I will answer.
Thank you, Jelal. Thank you very much. I'll write to you, and then I think you can share your presentation, some recommendations for courses, right? And then I can share it with the student developers.
Yeah.
Thank you, guys. Thank you, Jelal.
Thank you. Thank you for your time.
Mm-hmm.